Today I'm making clouds with a silver lining. Then I'll destroy them clouds and make it rain pure beautiful silver. Hello everybody, welcome to today's video. Today we're going to be talking about silver chloride and converting silver chloride into silver metal. Now everybody's got their favourite way of converting silver chloride, but today I'm going to show you the fastest way to do it, and in my opinion the safest way of doing it. First we need some silver to refine. So here we have got some 99% silver, we've got some sterling silver. This used to be a knife, it's no longer a knife. This was a Vesta box, used to keep your matches in there. It's 925 or Hallmark. And we got some Canadian tokens. There's them 3 Canadian coins. These coins are only 80% silver, and as you can see, after incinerating everything to get rid of any oils, maybe you can see, they've turned a copper colour on the outside. That's the copper coming through and oxidising. It's quite fascinating. But people ask, why do we refine silver? And that's the reason. You've got 925, you've got 800, and you've got 999. You want them all to be the same purity so that you know what you've got. If I was making a piece of jewellery, or if I was making a sterling silver knife, I'd need to know exactly what was in the silver that I'm using. So everything gets purified, everything becomes 100% silver, and then you can add fresh copper afterwards to make it 925. You can make your jewellery, you can make your knives, you can make your Vesta boxes and your lighters, and everybody's happy. But I'm going to get this outside and get some nitric acid on it, and then while that's cooking away, I'll explain to you some of the different ways of converting silver chloride and which way I'm going to use. So I'm going to start off with some dilute acid first, and then as it moves forward I'll add some concentrated nitric acid. Let's just get it started with a bit of dilute. Right, so first let's talk about a couple of methods I don't use. I'll give you a quick description and my pros and cons to each method. So first up is the metal displacement method. To do this, you first need to add some hydrochloric acid or sulfuric acid to the silver chloride. Then you need to add a more reactive metal such as zinc or iron, and then heat it and stir it. The pros to this reaction, none there are can think of. And the cons, the silver produced is almost always contaminated with the metal that you use to displace the silver with. And the reaction can take over an hour to fully complete. So I don't like using that one at all. The second reaction I don't use is everybody's favourite, the lye and sugar method. For anyone that doesn't know this reaction, it involves adding sodium hydroxide to the silver chloride to convert it to silver oxide, then adding sugar to convert the silver oxide to silver metal. Now the pros to this reaction are the silver produced is normally above 395, it's very pure, and it's also quicker than the metal displacement method. The cons, it requires constant vigorous stirring of the silver chloride when you're converting it into the oxide to make sure you get it all that silver chloride converted to silver oxide. And also it's extremely exothermic. If the ingredients are added too quickly, it'll boil over rapidly, spit out boiling hot silver and caustic soda. Hate it. My preferred method is the ammonia ascorbic acid method, which is what I'll be showing you today. And I'll explain a little bit more about it shortly. But first, I need to convert this silver nitrate to silver chloride. Okay, so we've got a silver nitrate solution, which we're now going to convert into silver chloride. And for the silver chloride conversion, I've got some sodium chloride solution, which is just a clever way of saying salt water. You get that poured in. And you'll get beautiful clouds of silver chloride. So what's happened is a double displacement reaction. The sodium chloride has gone into the nitrate solution and converted the silver nitrate to silver chloride, which is this white precipitant. And the copper nitrate has been converted to copper chloride. Now, because the copper is soluble in water, but the silver isn't, the silver precipitates and the copper stays in solution, giving a really good separation. Now, it doesn't matter which method you decide to use. The next step is the most important when performing silver chloride separation, and it's the rinsing. All of the copper chloride solution needs to go. By rinsing with boiling water, you'll remove everything that isn't silver, and this is what's going to get you to the highest purities. Now, what I like to do is wash the silver chloride with boiling tap water straight from the kettle, and I'll wash the silver until the rinse water looks completely clear. Then I can test it with ammonia. If there's still copper in the rinse water, I'll continue until there's no reaction with the ammonia. After this, I'll wash the silver twice in distilled water just to remove any chlorides or anything from the tap water. So in the test tube, I've got some tap water mixed with a splash of ammonia. When I test the rinse water, I can stand it next to this control mixture. If there's no copper in solution, the test will look exactly the same as this mixture. To the naked eye, this rinse water looks really clear. There does appear to be a blue tint through the camera though. And after adding the ammonia, you can see that deep blue colour indicates there's still copper in the water. So I'm going to have to continue washing. So after washing with another half a litre of water, you'll see that after adding the ammonia, the rinse water is now exactly the same as the control mixture. So now we can start the conversion from silver chloride to silver metal. So to dissolve the silver chloride, I've got some household ammonia, it's around 9%, and some ascorbic acid to precipitate the silver from the ammonia solution. I can typically get around about an ounce of silver to dissolve in half a litre of ammonia. So I've got probably about 2 ounces here. So I might have to do this in 2 batches. So when I pour the ammonia in, the reaction is actually instantaneous. That's pretty much saturated what I've already put in there. Just give it a little bit of a mix around and then I'll pour the rest in. And as you can see, when it settles, it's already took around about half of the silver chloride that was already there. So what I'm going to do is decant this solution off, and then precipitate what I've already got, and then I'll do the other half off camera. Now the precipitation is exactly the same as precipitating gold from Aqua Regia. All you have to do is pour in your vitamin C solution, and as you can see, the silver drops straight away. It clumps together really nice. It settles really fast, and this is going to make some of the purest silver that you'll see. This is absolutely beautiful when you melt it. I'll just let this sit and then give it 5 minutes, and then I'll decant that solution off. And there you have it, pure silver metal. What I'll do now is I'll rinse all this off. I'll convert the second lot of silver chloride, put them both together, wash them again, and then we'll get to melting. So all the silver's converted now. And what you get is this beautiful grey powder, all uniform in colour. Absolutely stunning. So what I'm going to do is because I can't fit all this into my crucible, I'll do it in sections. I'll pour it off into shot, and then I should be able to fit all of the shot into the crucible, and I'll try and melt it into a bar. And here's some of that silver melted. It looks absolutely stunning. It looks even better from this side of the camera. The camera doesn't really do it justice, honestly. But I'll get all this into the melt dish, and then I'll try and melt it into one big bar. Beautiful. Let's get all this melted. Not exactly my best pour, but look at that silver. It's absolutely beautiful. Such high purity. We'll get this weighed up. So for the moment of truth, 62.4. That's just under what I was expecting, probably a gram under. That's probably gone over in the rinse water when I've been rinsing the chloride. So this method, perfect for small refines. If you're going to do anything more than an ounce, 2 ounces, then it's always better to do the cementation onto copper and electrolysis. But if you found this video interesting, informative, give it a thumbs up. Comment your preferred method, how you like to do it. And I'll see you on the next video.